Welcome back to the last instructional video of this first module. We will learn about the methods to reconstruct an individual's stature, also known as their height, from their skeletal remains. First, let's consider why we are interested in knowing someone's stature. The world is filled with short people and tall people and lots in between. Between, as well as within populations, considerable differences in height are found. And these are considered normal in the sense that they're not associated with an abnormal endocrine change or disease or malnutrition. Variation in height is distributed in a normal bell curve with lots of people in the middle and fewer towards the ends, as is depicted here. And while on average men are taller than women, there is a lot of overlap between the two. A lot of variation in your height depends upon your genes. Research suggests that 60 to 80% of your height is determined by genetic factors, by the genetic predisposition you inherit from your parents, who in turn inherited it from their parents, and so on. But as many of you know, the realization of one's genetic height potential is dependent upon your environment, mostly upon a growth period with adequate nutrition and good health. So, one reason osteoarchaeologists are interested in stature is to compare the averages of different populations to see if one experienced a more harmful growth period than another. In particular, osteoarchaeologists have focused on comparing populations before and after major cultural changes. For example, before and after the Industrial Revolution, or before and after a period of conflict or war. And in that way, we can infer the presence and extent of environmental stress that a population experienced. In historical and modern populations, events such as war, food scarcity, lack of access to health care, and just poverty have a clear negative impact on someone's height. We will visit one application of stature research at the end of this video when we are fortunate to have an expert human osteology researcher and medical doctor, Professor George Matt, join us. He will speak to us about his stature research on Western European populations that spanned over 2,000 years. First, though, let's explore the methods we commonly use to reconstruct stature. So, if you think about all of the bones in your body that contribute to your height, from your feet up to your head, there are 30 in total, most in your spine, and you have an estimate of the amount of non-skeletal tissue between these bones. For instance, the intervertebral discs that exist between each of your vertebrae. You could measure each one of the bones, add in the soft tissue estimate, and then achieve a stature estimate. And indeed, occasionally this is done in osteoarchaeology. But in most instances, not all of the bones are present or well enough preserved to use this method, plus it's quite time consuming. So usually osteoarchaeologists will take measurements of the length of one or a few bones, especially bones from your legs and your arms, as these give the highest accuracy, and we'll plug these measurements into something called a regression equation, and voila, a stature estimate is produced. So how does this actually work? Well, it's actually quite simple. Scientists have measured the body proportions of thousands and thousands of individuals from different populations the world over. And it's been shown since the days of Leonardo da Vinci, in fact, you'll likely recognize his Vitruvian Man, that there's a strong correlation between the size of one body part and the size of another body part. For stature, it's been shown that the size of one bone is strongly correlated with the final size of an individual, with their height. This has been shown, for example, by Dr. Mildred Trotter, whose regression equation we will use shortly. Because the leg-long bones, the femur and the tibia especially, contribute the most to height, they have the strongest correlation with height. So we can take the length of the femur, for example, plug it into a regression equation, an equation built from these data on the relationship between its size and a person's height, and we'll receive an estimate. The estimate won't be an exact match, of course. There's a plus-minus factor of at least a few centimeters that must always be kept in mind, but we can usually get pretty close. It's important to keep in mind that we must use population-specific regression equations as much as possible, because different populations and geographic groups have slightly different body proportions, which if not taken into account will decrease our accuracy. And also one must use sex-specific regression equations to account for differences in the relationship between different body proportions for males and females. Now, if you want to see this in action, there is a short optional video that you can find in the course documents where Anna Marin will show you how to properly measure a bone and apply the appropriate regression equation to achieve a final stature estimate. And now, on to the interview. It is now my pleasure to introduce to you a renowned human osteoarchaeologist and medical doctor, Professor Dr. George Matt. Professor Matt, thank you for joining us today. Professor Matt spent many years compiling and collecting stature data from male individuals from 21 different populations throughout the Low Countries. If you're not familiar with this region, it's depicted on this map. And these populations came from the period from AD 50 to 1997, thus over 2,000 years worth of data. This paper was published in 2005 in the International Journal of Osteoarchaeology, and you can see the title of the paper here. Professor Matt, can you please tell us about the main findings of your research?
Of the main findings, I think the main finding was that although we expected, because this is happening nowadays, that people are getting taller all the time, that they had been doing so for the last 2,000 years. But in fact, it showed when putting all data together and putting them in a graph, that the dominating action has been that we were getting smaller for over 1,800 years. And then with the Industrial Revolution halfway the 19th century, only from that moment we increased in length with an incredible more than 17 centimeters in 150 years. And that was quite a surprise, yes. And we think that is the result of decreasing and later improving socio-economic conditions of the populations. There are very parameters from what we could conclude that, yes.
Now, you had to make stature data from a number of different methods comparable, and also take into account that we shrink slightly as we age. Can you briefly explain to us how you were able to accomplish this?
Yes, that is to measure directly or by correction what the stature was of the males when they were in the ages between 20 and 30 years, because we assume that before the 20 years they may still be growing, and after 30 years they may be shrinking, or for sure they were shrinking. And we could compensate for that because we have formulas to do that. The measurements have been taken directly from the skeleton as people were found in situ in the grave. They have been calculated if we only had a bag of bones from their long bones. And we have, of course, also been measuring from the living people by having their standing heights straight away.
And finally, in the 11 years since your study was published, what new research has come forth about stature increases or decreases in different countries? For example, are the Dutch still the tallest in the world? And do we see clear correlations between increasing stature and improved socioeconomic status?
Well, to start with the last question, there are clear connections with especially the socioeconomic conditions of the people in the country. the better off they are, the taller they grow, not in one go, but through generations. And we do not have that much data from other countries. We have from quite a few Western European countries, and from that it shows that since the Second World War, the Dutch are the tallest. Before the Second World War, this used to be the Scandinavian countries, but they, from 1980, got stuck at just under 180 centimeters. And we have gained up until 184, but I have to say that the last 10-15 years we haven't been growing taller. So we seem to have, with the possibilities we have at the moment, socioeconomically, but maybe also genetically, this seems to be the limit for the average. Of course there are people taller and smaller, this is just about the average.
Very interesting.
I can add to that, to predict something about countries we know little about, that since in the 1970s we had a huge immigration in the Netherlands of people from North Africa who were far smaller than the average Dutch at that time, that their offspring is gaining stature in an enormous way and may catch up with the original Dutch population. That has shown from the data as well.
Very interesting. Thank you very much for sharing your research with us today, Professor Matt. In this module, you've learned about stature estimation methods from the skeleton. And you've seen an expert on osteoarchaeological stature research demonstrate how interesting and informative these types of studies are. You've no doubt learned a lot. In the online discussion forum, there is one question in particular we would like you to answer. And that question is, how tall are you really? What factors can come into play when you either measure your own height or it's done by another person, such as a nurse or a doctor or the employee at a driver's license office? Have you ever perhaps exaggerated your height a little bit? And did you know you really are a little bit taller in the morning than you are at the end of the day? This is true. Check out the online forum to find out why. Coming up next is a short discussion where we return to some of the big questions that we posed in the very first video, and we hope to see you soon.